Alright, so we're going to do a different type of example problem in this video. We have a sealed container of gas with a fixed volume that has its temperature doubled. What happens to the pressure of the gas? So we're given no numbers here. How do we solve this problem? Well, pressure, volume, and temperature are what we call state variables, where if we know something about the initial state of the gas, we can find out information about the final state of the gas. We are going to use the ideal gas law here as a ratio. So P2V2 over P1V1 is going to equal N2R T2 over N1R T1. So we divided the ideal gas law in state 2 by the ideal gas law in state 1. Now, do be careful when you're using this formula. A lot of times when you talk to the chemist, they knock this term out automatically. If you have a hole in your container and there is gas escaping, the number of moles is going to change because you're losing gas, which then affects the pressure, volume, and temperature of that gas. Chemists always assume that containers are always sealed, so they automatically knock out that number of moles. But do not do that in a physics problem. Alright, so let's work with this problem a little bit more. It is in a sealed container, which tells us that N2 equals N1. The amount of moles of gas hasn't changed. And it is a container that has a fixed volume. The volume in the formula is always the volume of the container. Remember, gas has no definite volume or shape, so it takes on the shape of the container. So volume is actually the volume of the container. So V2 equals V1. We're told that the temperature of the gas doubles. So the second state equals 2 times the first state. And we want to know what happens to P2 relative to P1. So automatically I go over to my formula over here, and I can cancel out the volume because these numbers are identical because these are equal to each other. So these two are equal to each other. I can knock these out because these two are equal to each other. And then I can knock out the ideal gas constant because the ideal gas constant is a constant. So I can rewrite P2 over P1 is equal to T2 over T1. Now I can use this relationship here. So T2 is equal to 2 times T1. This allows me to then cancel out the T1 and say down here that pressure 2 divided by pressure 1 equals 2, or P2, pressure 2, is going to equal 2 times pressure 1. So as the temperature doubles, so does the pressure. And if I had given you pressure 1, you could then plug it in and figure out what the new pressure is. So your goal when you see problems like this is to look for keywords like is the container sealed or does it have a leak in it? Is the volume fixed or something happened to the volume? And by how much? Is it cut in half? Is it doubled? So you can write volume 2 in terms of volume 1. Same thing with pressure and temperature. What is happening to the pressure and temperature? So that you can write state 2 in terms of state 1.